Is the video coming? I have already streamed.
Yes, sir, the video is coming.
Okay, okay. So let us start then. Uh, Today we will be doing a very important algorithm which is being asked also. So once again, I'm saying, like you people have to be ready with copy and pen, okay? Because it's a step-by-step procedure. So if you miss one point also, you will not be able to catch the algorithm. Okay. So first of all, I have tried to explain the entire process through an example because that's what you will be asked in the exam. Okay, write an algorithm. So once you know the how it works, then referring to the algorithm is very easy. But if you get the example, then you can just see the algorithm and understand what is happening. So in exam, two questions will be asked. One is what is bank, and a problem will be given to you, and through the banker's algorithm, you have to check whether the problem has got deadlock or not. So it's a deadlock avoidance algorithm. So let us see what are the things what things we are having as of now. Now, first, before going to banker's algorithm, we already know that it's a deadlock avoidance algorithm. Okay, so that means futuristically we have to predict that this algorithm will give us deadlock or not. If it gives a deadlock, then we can take certain preventive measures to avoid such kind of situation. Now, what are the conclusions we can draw from here? So in Banker's algorithm, through Banker's algorithm, basically we will be able to tell the operating system which are the processes which will be coming. That means which will be executed by the CPU. Also, it will tell the operating system which processes are requesting for certain resources. That means they are requesting for certain resources to be given to them. And also through this like if we use this algorithm, also we will be able to know how many resources the process is requesting and how long it has to hold. So these are the 3 points that we can know using banker's algorithm. Now, based on the information, all this information, which information? The above three information, like which process coming, which is being executed, which process is requesting which resource, which process is waiting, okay, and which one has been waiting for how long. Okay, so depending upon that, the system will decide which process should be executed, which one should wait, and which one should not be executed at all. All right. Now, let us go to the example. So from here, you have to little bit write it down. Okay, so suppose we are given this kind of a problem. So what is the problem? We are having five different sections. This is the list of processes that we have. We have allocation table where we are given three resources. Okay, so resource A has got 10 instances, B resource B has got 5 instances, and C has got 7 instances. What are the resource? I have randomly taken A to be the CPU, B to be the memory, and C to be the printer. We can take anything, but here I have taken myself. These are the resources. Okay, so let's say 10 instances are there total of A that can be used from A, okay, by a process. 5 instances of B can be used by any process or group of processes. 7 instances of C can be used by different processes. Now, what are the allocation? Okay, so if we look here in this at the second table, what we can see is out here the zero, what will it mean? It will mean that not a single instance of A. What is A? CPU. Not a single instance of A has been allocated to. All right. Then B. What is B1? So what will 1 mean? B value 1 means what? That means not a single instance of, sorry, only one instance of has been allocated to B1. That means out of 5, one has been allocated to B1. Then again 0. So what this will indicate? It will indicate a zero instance of C. Zero instance of C means what? There is no instance. So no instance of C has been allocated to P1. Okay. So accordingly, similarly, these things will be given to us. Okay. Then out here, what we have the maximum need. That means the process needs. So P1 process process needs 7 instance of A. P1 process, again I'm saying, needs how 7 instance of A. Then process P1, 1 is allocated to P1, but how much does it need in total? 5. So process P1 needs 5 instance. Then similarly, process P1 needs 3 instances of C. Okay, so this is the need. So in exam, you will be having two things given. Two things will be given to you. This two parts of the table. This thing will be given to you. This will be given to you. How many processes are there will be given to you, and this total instances of process will be given to you. So this will be given to you, this section will be given to you, this section of the table will be given to you, the allocation and maximum need also will be giving to you. Okay, so what you have to make is two more section of the table, the availability of resources and the remaining need. Okay, this section of the resources you have to make. Okay, now when let us see the meaning of each one of them. So when I say allocation, what does it mean? It means how many number of instances of resources we have allocated. Like for example here 200, what will it mean? It means that 2 instance of A has been allocated to P2. Okay, again I'm saying 2 instance of A. What is A? A is a resource. A is a resource. What kind of resource? CPU. So 2 instance of CPU has been allocated to P2. Then what about this? What will it mean? No instance of B has been allocated to P2. No instance of C has been allocated to P2 in that way. Okay. Maximum need means what? This part. What does maximum need mean? It means one process demands how many instances of resources, how many instances it wants of that resources. Like for example, 753, what will it need? That means process P1 will need 7 instance of A, 5 instance of B, and 3 instance of C. So this is the need. It got this much, but actually its need was this much. This portion of the table will tell how much of resources we are being given, and this part of the table will tell us how much amount of resources we actually need. Okay, so that is the difference. Now, this is the total resource. This is the total value of the instances of each of the resource, but some of the instances has already been allocated in the allocation table, we know, isn't it? So how much is remaining from the table we have to find out. So how do we find out? First of all, we'll total all of them. So I total this one. 2 plus 3 is 5, 5 plus 2 is 7. Then B also I will total. 1 plus 1 is 2. Then again for C I have to total. So 2 plus 1 is 3, 3 plus 2 is 5. So this means what? This is the total allocation of resources for all the processes. Okay, so that means out of 10, 7 has been allocated. Out of 5, 2 has been allocated. Out of 7, 5 has been allocated. So if that is the case, so how much remaining? 10 minus 7 for A. For the first one, I have to subtract 10 with what? 7. So 10 minus 7 is how much? 3. That means A has got how many instances now? Remaining 3. Then B is also, I have to subtract the total minus which has been allocated. So 5 minus 2 is how much? 3. Then again 7 minus 5. The total instance left for C is how much? 7 minus 5. So how much is that? 2. So in that way, okay. Now, what are the other two parts of the table saying? Okay, so available means when we subtract something from the total, we subtracted, right here. 10 minus 7 is 3, then 5 minus 2 is 3, then 7 minus 5 is 2. So what is the availability of resources now? 10 minus 7 is how much? A should be having how much? 3. Then again 5 minus 2 is how much? 3. And then 7 minus 5 is how much? 2. So that thing will be maintained here. 332. How did we get 332? We subtracted total instance of A minus the allocated value of A, total instance of B minus allocated value of B, total instance of C minus allocated value of C. So we are getting that value. Okay. Now, okay, then a remaining need. This is one section of the table. So how will you make? You will subtract this part of the column maximum need, whatever is there, minus the allocation. So whatever is the allocated one. So this this table, this table minus this table, the values of this section of the table will give you the value here. Okay. So let us see how do we do this. So first case, this 332, is it clear how did it come? This 332, from here it is coming. We are copying paste. And how does 3 came? We did A was 10. So 10 minus 7 was 3. Like that, B also. Isn't it? I think we have already shown B was 5. So 5 minus 2 is how much? 3. Then again, 7 minus 5 is how much? 2. So those values after subtraction we are getting here. Okay. So that means this is the new, you can say, value of instances of resources that it is available. Okay. Now, let us come to this section. So what is it saying? Remaining need, how will we get? We'll get maximum need minus the allocation. So maximum need. So what is the maximum need here? 7. What is the allocation for A? We have to subtract A with A, B with B. Okay. So see, 7 minus 0 is how much? 7. Then again, 5 minus 1 is how much? 4. Then 3 minus 0 is how much? 3. So this is basically the need of process P1. Okay. Okay. Yes, you have to stop because okay. Uh, which part I have to explain? Okay. So this one, this is the table that you will be given. Okay, this things, this will be given to you, this section of the table, and this will be given to you in question. Then this part of the question also will be given. That means A, B, and C are resources. There are 10 instances of A, 5 instances of B, 7 instances of C. That means you can use resource A for 10 number of times, 5 B for 5 number of times, C for 7 number of times. That's what the instances is being said here. Now, allocation is this one already been given to you, okay, and how much you need, that also will be given to you. So let's say, for example, this much is given already to the process, and this part of the table will basically tell us how much instances more a process will need. Like, for example, A for P1, we need 7 instances of A. That means 7 times A has to be utilized by P1. Then 5, B means what? 5 instances of B will be utilized by P1. 3 instances of C will be utilized by P1. Okay. Now, next is what we have to do is we have to find the sum total. This will not be given. We have to find this part, this sum. So how will I find the sum? You add. So all of you, you write in the copy, okay, this one, because I'll be going to next like page. So this data will be lost, okay? So it'll be easy for referencing. So first we will add 2 plus 3 is 5. 5 plus 2 is how much? 7. Then 1 plus 1 is how much? 2. So B, all the B values will be added here. Okay, then next is what? For C I have to add. So 2 plus 1 is 3. 3 plus 2 is 5. Till here, I think it's clear what we have done. Okay. Now, next, see, this is very critical. I have like for A, 7 instances are already used, right? So total was how much? 10. So if I have used 7, 10 minus 7 should be how much? 10 minus 7 should be how much? It should be 3.
Three.
So 3 instances of A is like available. Okay. Then again, next is for B. So B, 2 has been used. Okay. But how much was the total? 5. So how much is available? I have to subtract 5 minus 2. So 5 minus 2 is how much? 3, isn't it? Okay, then next is for C. So for C, 5 instances of C are utilized. That means 5 out of 7, 5 I have already allocated, I have given. So how much is remaining? 2. So this value of 2 has to be updated in this available section. Okay, then this remaining section, all you have to update. Here only one step only we have to like highlight. Here, how will I find? I will use this formula for the remaining need. Okay, so for the first process, how will I find? This is the formula: max need minus allocation. So what is max need? This, this one for P1. Okay, so 753. What is 1? So I have to subtract 7 minus 0, A with A, then B with B, 5 minus 1, and then 3 minus 0. So how much will I get here? 7 minus 0 is 7. Then next is 5 minus 1 is 4. You people also write, okay? Then 3 minus 0 is 3. Okay, so similarly, again, I have to populate the other section of table again like this. A with A, so 3 minus 2 is how much? 1. Okay, so that I have done here. Okay, so like for example, 3 minus 2 is how much? 1. Then 2 minus 0 is how much? 2. Then 2 minus 0 is 2. Okay, then again for the third one also, then 9 minus 3 is 6. Then 0 minus 0 is 0. And then 2 minus 2 is also 0. Then the fourth one, 4 minus 2 is 2. 2 minus 1 is 1. 2 minus 1 is also 1. Then the fifth one, 5 minus 0 is 5. 3 minus 0 is 3. And 3 minus 2 is 1. Okay, so like this part is optional. Like I wrote P1, P2, P3, P4, P5. That means this is for like process naming. Okay, because already I have named here. So if I put P1 again also, there is no harm. If I don't put here also, it's no harm. It's the same. So till this part of the construction of second table, is it clear, everyone? I think others also, everyone clear? Okay, so I'll proceed. Now, let us go to the next section. So this one, you better write it down. Okay, so I assume that you have written down. Okay, so now we will start comparing with the need and to the with the availability. Once again, I'm saying after this, you can write it down also. Now we will compare the section of the table with the need, the remaining need that we have, with the instances of resources which are available. Okay, so first I will compare with P1. All right, so if I compare with P1, what do I see? I have 3 instances of A, but then I need how many instances of A? 7. So can I give like this? Can I give? No. Why? Because if I'm having 3 units, like in junior class, no? Like for example, you have 3 toffees, but you need 7 toffees. Can we get 7 toffees if we have in hand 3 toffees? We can't, isn't it? So this is not possible. Okay. So that's what I have said. In first case, P1 needs cannot be fulfilled. Okay, so P1's need. Why P1's need cannot be fulfilled? Because it requires more than what is there in the stock, isn't it? So it requires 7, but how much do we need? 3. So it's not being able to fulfill. For B, it's okay. Oh no, for B also it's not okay. It needs 4, but how many instances of B are there? 3. So it fails. Okay, so if any one of the instances also it is being unable to get from the availability table, then we have to keep as it is. Okay, so what do we do? So in first case, P1 cannot be fulfilled, so P1 will not be put in sequence. Okay, so it will remain there only. If we cannot fulfill, this is one of the most important point. If we cannot fulfill any of the processes which is there, okay, then we say that deadlock has occurred. So this we will see at the end only whether any process will be left or not. If suppose any process will be left in the table, that means we are unable to satisfy the resources, okay, to them, then we say that this is a statement, or the problem which is given to us is a problem where deadlock will take place. Okay, now let us check p2's need. P2's need can be fulfilled as all the resources in the remaining need is equal to or less than the available resource, is it? So let us check. Okay, so this is the availability of p2. What is the availability of p2? Okay, for this is p2, so what does it need? It needs one instance of A. But how many instances of A we have? Three, isn't it? It needs one instance of A. So how many instances of A does it have in stock? Three. So easily we can allocate. Then for B, instance of B, it needs how many instances of B? Two, isn't it? But how many instances of B is available? Three. So this is also correct because we in stock we are having more than demand. Okay. Then C also, how many instances of C we are having? Two, isn't it? But in stock, how much is there? Two, so we can fulfill. Aram se we can give, correct? So if this P2 is fulfilling the condition, why? Because the need that is there is lesser or equal to the availability of the instances of resources. Hence, we will phase P2 out from the system. Okay, that phasing means what? That means P2 will be given to the CPU for execution and it will be phased out. Okay, so P2's need can be fulfilled as all the resources and remaining need is equal to or less than the available resources. Okay, so what will happen if that is the case? So there will be some updation. What updation will take place? This is little bit crucial. Okay, so what updation will take place? If you look here, in this P2's case, once this P2 has exited from here, once P2 has exited, let's say from here, okay, this is just for temporary purpose, I'm deleting. Okay, it has exited from here. So what happens? Whatever P2 was holding the resources, again I'm saying, once P2 is been allocated the resources, he has executed and is exited from the system. So whatever allocation value it was holding, no, some instances it was holding, that he has to release. So once he releases, that means that has to be added up. These instances, once P2 is out from the system, then the resources also he will release. So once the resources he releases, then whatever it is available in the stock, it will be added up. So once it is added up, then what will happen? What will happen? This 3 will be added with this 2. So 3 plus 2 is how much? 5, correct? Then again, this B will be added with this. So 3 plus 0 is how much? 3. Okay. Then next also for C is 0. So 2 plus 0 is how much? 2. Okay. So first that means P2 has exited from the system because he checked with the availability, how much availability of resources was there. Once it got the resources, it exited. Now the moment P2 exited, that means whatever resources it was holding, he released that also. Now where will these resources go? These resources will go nowhere, but it will be added to the availability stock. So it will be added. Each of the instances will be added. So P2 will be out of the system. Now we will compare the updated value of availability with P3. So let us go down. Okay, so this is the new section. So this is the availability. I did not do anything. The same thing only I'm writing. So I'm comparing this availability of resources with P3. So what will P3 do? So we'll compare. So 6 instance of A is required, but how many instances available of A5? That means 5 units of A is there, but I need how many? 6 units. So availability is less, isn't it? Like you need 6 toffees, but how many toffees there in the shop? Only 5. So this P3 we will not be able to fulfill. So P3's need cannot be fulfilled as A resource request is more than the availability resource. Okay, so that will be dropped. Then next we will be checking for P4. So let us check one by one. How much I need toffees? Let's say I'm just saying toffees here. 2 toffees. In stock, how many toffees we have? How many it is there? Five, right? So what do I do? Will we be able to fulfill the need? Yes. Then again, here how much do I have? P3 is not P4. I have one. Okay, I need one, but how many is available? Three in the stock. So it's hit. Then again here P4, how many I need? One. So how much is available in the stock? Two. So will I be able to allocate the CPU to P4? Will I be able to allocate? Will I be able to allocate?
Yes, sir.
Okay, very good. Others also, I think, are understanding. Okay, so let us continue. So I'll be able to allocate. Now, the moment I allocate, what I have to do, that means P4 will be given to the system, and whatever the resources P4 is holding, that has to be released. So what resources P4 was holding? One, this one was the resource P4 was holding. So what will it do? It will be released. So once it's released, where will we go? It will be added into the availability of stock. So once it is added, so I have to update this one. So 5 plus 2 will be how much? 7. Then again, 1 plus 3 is how much? 4. And then again, last में कौन सा आएगा? 1 plus 2 is 3. Okay, so P2 has gone, P4 has gone. Remember who the order, the cycle. Okay, all right. Okay, so P2 is gone, P4 has gone. Now I have to check P5 with the availability. This only the algorithm is saying, okay, if you check also, so I will check, okay. So will its needs be fulfilled? Let's see. 5 instance of A I need, but in shop I have 7 instance of A. Very good. I have more than how much I required. 3 instance of B is there, but I need how many instance of B? 4. Okay, so it's more again because in stock I have 4 toffees. I need just 3 toffees. Similarly, I need just one toffee, but how many toffees are there in stock? Three. So this also is correct. So P5's need can be fulfilled as all the resources in remaining need is equal or less than the variable. So once this is done, what I can do? I can release P5 from system. So I release. So the moment I release, what will happen? Whatever allocation value P5 was holding, that will be added to the stock. Okay, so P5 is out now. So its resources also it has to release. So it will release. So these values will be added with the available. So how much will it be? 7 plus 0 is 7. Okay, then 4 plus 0, I think it's 4. Then 2 plus 3 is 5. Okay, so this is the availability. Now, what has happened? This many resources are available. Now, there is a competition between the two. So, since we are following a pattern, so once P5 is done, we are going back to P1 again. Now, we will compare again with P1. Okay, so once if I compare with P1, I will check. I need 7 instance of A. I have 7 instance of A. No problem. I have 4 instance of B. I have 4 instance of B. Not an issue. I have 3 instance of C. I need 3 instances of C. And how many instances of C are available? 5 instances of C. Okay, that means I have 5 toffees in stock and I need 3 toffees. So can I allocate P1 to the CPU? Will it be possible? Can I allocate
Yes,
P1 to
sir.
CPU?
Mm.
Okay, again, I'm saying we just have to do a comparison. That means here I need to check. Okay, I need to check now because the choice is between P1 and P3. So I'm checking for P1. I'm checking I need 7 instance of A. In stock, how much I have? 7 instance of A. No problem. I can go. I have 4 instance of B. In stock, how much I have? 4 instance of B only. Very nice. I can go. I need 3 instance of C. In stock, how much do I have? 5 instance. So that means in stock, isn't it still 2 instance will be left? So definitely I can go for process P1. So process P1 will be given to the CPU. Process P1 will be given to the CPU, and whatever resource P1 was holding. This was the resource, right? P1 was holding. So that has to be added here. So if I add that, what will happen? 7 plus 0 is how much? 7. Then 4 plus 1 is how much? 5. Then 5 plus 0 is 5. Did I make any error anywhere? Okay, let us. Did I make any error? I think no. Okay. Then next, let us check now. The last is with P3 only. Okay. So let us go down. Last is with P3. Now, one important thing you have to remember is that if suppose P3 remains, that means whatever is available in the stock is lesser than the what we need. And if this remains, suppose we cannot fulfill its demand, then this will be a deadlock. Okay, so that means all the processes have to be exhausted from this part. Remaining need table has to be empty. Then only we will be able to say that there is no deadlock in the given problem. But even if one of the process also remains in this section, then this problem will contain deadlock. So that part we have to remember it very, very clearly. Okay, so now let us check. Okay, now let us compare P3 with the availability. So I have 6, correct? I have 6. I need how much? 7. So I have more because in stock I have 7 toffees. I need how much? 6 toffees. Very good. For B, I don't need anything. Okay, availability is 5, but I don't need anything. For C also, I don't need anything. So will I be able to allocate P3 to the CPU?
Yes, sir.
Okay, okay. So ultimately, this will freeze out from the system. So it will freeze out. So once it freezes out, what will be the final table? So it's out from the system. So whatever value P3 was holding, it will add. So this was the availability. So I'll add 7 plus 3 is how much? 10. Then 5 plus 0 is 5. Then 5 plus 2 is how much? 7. So what was the, you can say the total number of resources, if you have remembered? What was the total number of resources when we started? A was 10, B
10
was
resources.
5, C was 7. So did we get these values back after so much of iteration? Did we get these values back or not? That is, we got A is 10,
Mhm.
B is 5, and C is. And since we could allocate all the process to the CPU, so we can say that there shall be no deadlock. Now, if suppose you are asked that what is the sequence of these process, like there, like the pattern through which we had uh, uh, given the process to the CPU. Okay, so we will be able to say very clearly P2 went first, then P4 went, then P5 went, then P1 went, and at last who went? P3. So following the sequence, we can say that there will be no deadlock, and that is the reason this sequence is called your safe sequence. Okay, so you can comment in the section. Was the Banker's algorithm tough?
No, sir. It was easy.
Okay, but we have to be very careful with the this adding part. Okay, otherwise there will be confusions. Okay, in the thing. But these questions are being asked in gate exam also. So suppose in certain time if you write gate, then also it'll be helpful for you. So all these students who are available right now, did you all understand or not? Okay, because only few are saying. Shabazz didn't understand. I think it will be almost 6 to 7 months. What about Mosami, Mos Shankanan? So many I can see. Himangshu. Then Biswajit also. Biswajit is always silent.
Bhujesh.
Bhagyashree. Okay, I'll explain that last part. For Shabazz, this video will be recorded. So, okay, I will explain that adding part. Adding part means which one? Because that I have to be clear. Adding part means which? These values here, in here, the adding part you are saying.
Yes, sir.
Okay. Okay, I'll just show maybe with two process. And
Actually, I
Ishita,
missed the first part, sir. That's why I'm not getting.
okay, okay. I will show. I'll just show two process and Ishita how we are getting that last one. No, those values again. Okay. So let us see. Let me go above. Let me see at this situation. So I my availability is this much. My availability is this much, and I have three processes remaining. So I have to compare. Okay, what I'm comparing also I have to check. Actually, I have populated all the tables, so those values are lost. So look here. Okay, from this, let's say for example here. Okay, you just look for P1. For P1, where is that complete table? Okay, let us go here. P2 has been executed, it's gone. Now, P3 will be compared with the one which is available. So let's see, I have 6 here, I have 5 here. How much I need? 6. How much I have? 5. Will I be able to get 6? No. Why? Because the availability is 6. But, oh sorry, the need is 6, but the availability in stock is how much? 5. So P3 I cannot process. Next, whom I will process, I'll try to compare with P4. So compare P4 instances of resources with the one which are available. I need how many? Two instances of resource, but I have available how much? 5. Very good. I need one. I have availability of 3. Not a problem. I have one instance of C. I have how many instances of C available? Two. So P4 will be like be given to the CPU, and P4 once it is given to the CPU, it will be removed from this table. It will be removed from this table, but once this P4 has been removed, then whatever resources it was occupying, this was the resource that was it was occupying. So this one it has to be added with this one it has to be added with this one. So if I add with this one, that means these two have to be added. This is the availability. P4 is successfully out of the system. Once P4 is out, what it was holding? Under the allocation, no, these resources it was holding. So this resources has to be added with this. So once I add, how will I add? A with A. So 2 plus 5 is how much? 2 plus 5 is 7. 3 plus 1
Sir,
is how much? 4.
whichever is removing, whichever we are removing, we will have to add that part.
Yes, whichever way we are moving, whoever it is satisfying, whichever process is out, who has been executed, that allocation of resources have to be added with the availability.
Okay.
So that was this updation happened. Is it clear now?
Yes, sir. Thank you.
Okay. And Ishita's question was how we are getting that 10 at last, no? Isn't it? So this one, look here. In the second last till I had reached till here 755. Okay, process P1 should have been there for understanding. I deleted, that's why that problem occurred. Okay, Now you compare. See, now it will compare this with. So I have seven instance of A. But process P1 needs how much? Seven. So it can fulfill. Then process P1 needs how many instance of B? Four. In stock, how much is there? Five. Then process P1 has needs how many instance? Three. In stock, how much it has? So will it be able to fulfill or not? It will be able to fulfill very easily. So the moment this is able to fulfill, what do we do? This is out. He executed, P1 got executed, he's out of the CPU. Okay. So the moment it is out, that means whatever resources P1 was holding, what was the resource P1 was holding? What was the resource P1 was holding?
0 1 0.
Sorry. I think P1 will go first. Last was P3. No, I made an error. Okay, please don't mind. This should have been there, not P1. P1 is out in in this table only. Made a mistake. Sorry. Okay, this was the P1 was already out. Actually, it should have been P3. Okay, so now what will happen? It will compare 6 with 7. It's more. Then here it is 0. It doesn't need only anything, though 5 is available. Here also it doesn't need 5 is available. So what will happen? This will be out. So P3 is out. Now whatever P3 was holding, what was P3 holding? This value P3 was holding, isn't it? P3 was holding this value. So this resources, instances of resources that P3 was holding, that has to be added with the availability of resources. So it'll be 7 plus 3 is how much? 10. 5 plus 0 is 5, and 5 plus 2 is 7. Now, when we started, we said that A was 10, B was 5, and C was 7. So that means very efficiently we have utilized the given resources. One another point is that if one process also would have remained, okay, it would not be have been able to fulfill the availability of resource, then we say that that time a deadlock would have occurred. So anything? Now, is it clear? Others? What about others? Okay, very good. Now, the next topic that we have is the resource allocation graph. Okay, so resource allocation graph, what is it? We have to know. Okay, so resource allocation graph is a method again to find out if deadlock is there or not for a given situation. That means we will be given a certain situation. So based on that situation, using this method, RAG or resource allocation graph, we have to derive that whether that situation contains deadlock or not. Now, certain symbols that we have to know is every graph will have a vertex and an edge. You already know that, right? So the vertex is again classified into two types: process vertex, that means a vertex which will represent a process, and a vertex which will represent a resource. So that's the reason it is called process vertex and resource vertex. Now, this resource allocation graph is for single instance, okay? So when only one instance of because there's multiple instances also there. Then resource vertex again it can be classified into two types: single instance and multiple instance. Like for example, in single instance, we may have just maybe CPU, we may just have let's say printer. Okay, so that is a single instance. Like but registers, there can be so many registers, isn't it? So those kind of resources are multiple instances. Okay, then so like a graph has got vertex and edge. So again we have classified two kinds of edges in resource allocation graph, that is the assign edge and the request edge. Now today I have taken two problems. So let us, for example, this diagram. Okay, I am considering this graph. Now, theoretically, if we see, does this graph has a deadlock? Theoretically, I'm not implementing resource allocation graph method, yes, but do you think that this graph will contain a deadlock? What do you suggest? Okay, I'll show you once again the diagram for 1 minute. Just check. This is the structure. These are the two resources. These are the two process p1 is given allocated resource r1, but it is requesting some resource. Process p2 is allocated some resource r2, but it is still requesting some resource. So do you think this one will contain deadlock? There was a property in theory, remember yesterday I had said, yes, why will it contain deadlock? What is the reason, main reason? What is the reason? That is the question, the justification has to be there. But why? My question is why. You are correct. Deadlock possibility is very, very high and it will contain. But what is the reason? The reason has to be there. Yes, because, okay, okay, all right. So one condition, someone said because they're having a resource but they're asking for something else. So what was that condition? The criteria for having a deadlock? Hold and wait, isn't it? What was the criteria? Hold and wait. So that was one of the situation. Then another criteria that it is having right now, what is it, the other criteria? Someone said because the loop is not stopping. Yes, it is a loop kind of structure. That means it is going on and on. We don't know where is it stop, is it where it will coming to a halt. So that this situation theoretically, yes, we say that it is a situation of deadlock because first it's hold and wait. That means some process is holding a resource, but at the same time it is waiting for some other resource. We already said that that was one of the criteria. Then it is a loop structure. It's a cycle. So that cycle should not be there, isn't it? So this is a situation of a deadlock. Now I will be drawing the resource allocation graph for this one. So let us see, we have to process p1 and p2. Okay, so we will go line by line. This the solution I've already done, so that's why first let us see in the first set. Okay, so let us see p1. So what does p1 is having? P1, we will make two sections. One is the allocate section and one is the request section. In the allocate we will be putting the values for those resources which has been assigned, and in the request part we will be putting the values for those part of the resource which has been requested by that process. So let's say for p1 has been allocated which resource? R1, it has been assigned. So I will put the value of 1. This 1 will basically symbolize that R1 has been allocated to P1. It's kind of like a Boolean value, you can say. Okay. Then R P1, okay, the P1, what about R2? Has P1 been allocated R2? No. Okay, so it is 0. Then for P2, P2 has been assigned with which resource? R2. So for P2 of R2, I will have 1, but it is not having R1, so it will be 0. Okay. Now, let's say, for example, in this situation, in this situation, what is my availability of resource? This has not come only as yet. This has not come. Okay, this has not come this way. So I don't have any resource left because R1 is given to P1 and R2 has been given to P2. So the availability of resources 0 0. That means R1 is also 0, R2 is also 0, the second coordinate. Okay, so it's a coordinate of R1 comma R2. It's both 0 0. Now when I see the request section, I'll go back again to the table, sorry, to the diagram, state transition, to this graphical diagram. So for R1, okay, is it requesting sorry, For process P1, what is it requesting for? It is requesting for, oh, this is P1. For process P1, it is requesting for whom? It is requesting for process P1. Yes, sorry, yes. For process P1, it is requesting whom? R2. So process P1 is requesting R2, okay? And R1 is 0, okay? Because the R1 is already allocated. Then what about P2? P2 is requesting whom? P2, P2 is requesting whom? R1. So P2 is requesting whom? R1, and P2 for R2 is 0. Okay. Now will we be able to satisfy the problem or not? So let us see. This is 0 and this is 1. Okay, so we will check 0 instance of R1, and availability is how much? 0. So no problem. One instance of R2 request of resources there from P1. But do we have any R2 here? No, we don't have, because why? Already we have allocated in this section, in this part of the table we have already allocated. After we have made this one, we have made the availability, then we have come here. Okay, so when I compare this one with this one, I cannot allocate in R2, because already that has been allocated someone else. Similarly, for the second one, will I be able to it is requesting for R1, so I will do a lookup. Will I be able to take R1? No, because R1 has already been allocated to P1. Okay, so I don't have any resource in hand, in stock available. So for P1 also, we cannot fulfill the request of P1 because no resources are available, and similar is the case of P2. So this condition through which we represent through a resource allocation graph, where basically there is no availability of resource based on the request, then we say that this is a situation of deadlock. So any questions? One more situation we'll take. Okay. Others, what about Mehboob, Shankanan? Others, they are not replying. Is it okay or not? You all have to say. Teerth also, Tapan. Yes, here from the diagram only we can check. The only thing we have to make is the table. So that part we have to make. Then apart from that, from the diagram only we can. Okay. And the table is also one time only. Yeah, one diagram I will do. So first, like if the diagram is complex also, first you have to make the table. You have to say who, how much is allocated, who is requesting what. So once the table is made, then like things are easier. Okay. Okay. So let us see one more case. So something like this. Okay. So I forgot to write assign request, so you people can know. So let us see from here what do we have. Mm, okay. So look here. This is little bit different from the above one. So look here, what we have, P1 is assigned R1, but uh, P1 is not requesting anything. P2 is assigned R2, isn't it? And P3 is not assigned anything, however, it is requesting R1 and R3. So this we have to check whether it's a situation of deadlock or not. So how do we check? Again, we make the table. So P1, P2, P3. So for the first one, P1, P1, क्या है P1 में allocation. What is allocated? R1 is allocated. Other things are R2 is not allocated. Okay, then P2. Again in P2 we will check. So P2, what do we have? R2 is allocated, but it is not requesting anything, isn't it? So is 0 and it is allocated R2. Then for P3, P3, do we have any allocation here? No, we don't have. Neither R1 nor R2. So it is 0, 0. Okay. Now, how many resources we have here? Two resources. So all the two resources are allocated. One in case of P1 and another in case of P2. So the availability of resources, how much? 0, 0. Now, next case, I will make the request section. So who is requesting? P1, is P1 requesting anything? No, neither for R1 nor for R2. Neither of the resources it is requesting. The next is for R2. Is it requesting anything? No. Oh, sorry, P2. Is P2 requesting anything? No. It already got R2 and it is not asking for any resource. Okay, so it'll be 0, 0. And P3, it is requesting for R1 as well as R2. Okay, so this is the situation, this table we have to construct. Now let us see whether this one uh, this thing, what is it called, deadlock situation or not. So first we will try to go with P1. So P1, let's see, is P1 requesting anything? No, P1 is not requesting anything, isn't it? See, it's 0 here. P1 is not requesting anything. It is not requesting R1, it is not requesting R2. So P1 can be given to the CPU and P1 will be released. Now, the moment P1 releases, then whatever resources we had given to P1 will be added. So what was the availability of resource initially? 0, 0. So now when P1 is released from the system because it doesn't need anything only. So it will be given to the CPU, get executed, and will be out. So P1 will be out. The moment P1 is out, whatever it was holding, it will be added to the availability stock. So it will be added here. So it will be how much? 0 plus 1. So how much will it be? 1. And then is 0 only. So 0 plus 0 is 0. Okay, so P1 is done. This part is done. So let me highlight this one that it is done. Okay. Now, next we will come to P2. Now, P2 also we will check. What is its request? It is 0, 0. Okay. Now, so we have stock 1, but it is not requesting anything. Okay. Then similarly, here also there is no request for the alternate resource. So similarly, this also will be given to the CPU, get executed, and P2 will be out of the system. So the moment P2 is out of the system, then whatever resource it was holding, that also has to be added. So now this will be added to the availability of resource. So how much will it be? 0 plus 1 is how much? 1. And then 1 plus 0 is 1. So this is my new availability of resource. Then again, I have to compare with P3. So P3, what does it need? Oh, it needs two resources, 1 and 1 here also. That means two resources it needs. So we'll compare, do we have two available resources? Yes, we have two available resources. So P3 will consume the resource which is available and will be given to the CPU and will it be exiting from the system. So all the resources are consumed. So we can produce a safe sequence again in this way and we can say that no deadlock occurs. But here basically we'll be given the graph and from the graph we have to derive the conclusion. So any question in resource allocation graph also? So Bankers actually was the toughest of all from all the algorithms. Okay, then we have concluded the topic. What else was algorithms were there which was very tough? You were always saying. I forgot now. because next class maybe I'll do. Tomorrow I will not take. I think sir will take. He told me, no. So tomorrow I'm leaving for sir. So Monday again I'll take. Which are the algorithms? Other algorithms that were there? Could you remember which were the other algorithms? In the assignment, some were saying no that assignments were there. So those notes you share in the WhatsApp group because everyone may not be available also. So Arbas, I think you can do that, no? That sharing of the bankers algorithm notes.
Yes,
Today's
sir.
one.
I'll do it later.
Okay. Okay. So any, I think everyone clear resource allocation and both the topics very nicely. And what else is there? I forgot. Okay, I'll just check the syllabus and then maybe next class. I think next class, let me try to do more algorithms on this process scheduling, no? All those round robin, shortest job first. I think those also you need, isn't it? Numericals also.
Eh, Yes, sir. We also need that one.
Okay, okay. Then that one. Okay, then I think today I think it's sufficient. I thought I'll take more time because Banker's algorithm was very huge. Okay, but it finished. Yes, dining philosopher's problem. I'll be doing that in the next class. I think that is the only algorithm, no, in process synchronization, bounded buffer and dining. Okay, the next class I will handle these two. And what about monitors? Did I give a question on monitor in assignment? Okay, okay. Then okay, next class I'll do dining philosopher, bounded buffer, and monitors. Okay, so with that process synchronization will be done, and then I will go to scheduling algorithms. Yes, all these issues I will be doing. So once this is done, then I'll go to those. Then I think 2 more weeks. Then I think theory I should be able to finish of OS. Okay, then I will start with the practicals. Okay, okay. Then thank you everyone for your